Hello and welcome again to this series of videos where we are looking at force, impulse and momentum and the applications. In this video we are going to bring in now another concept that is very important, and this is the concept which involves conservation of momentum, the principle of conservation of momentum. It's important that you study these videos the way I have outlined them in the video description. I have numbered them. It's important that you study them that way in order for you to be able to understand how one concept gives rise to the next one. Don't study them at random, because if you study these videos at random, then at some point you might get lost. And if for some reason you like how these videos are progressing, consider subscribing to this channel, because it is going to add value to my channel. Okay, let's go right ahead and look at the principle of conservation of momentum. Did I say the principle of conservation of energy? Although it applies, what I meant is the principle of conservation of momentum. What does it state? It states that in an isolated system of colliding bodies, the total momentum remains the same. It remains constant. It never changes. Now, what is an isolated system? An isolated system is a system where there are no external forces acting. No external forces acting. If there are any forces which are acting on the system, then they are internal. There is no external force which is acting on that particular system. That is what the principle of conservation of momentum talks about. And in order to understand how this principle is applied, we are going to look at a question. And in this question, we have an object which is an arrow of mass 50 grams moving with a speed of 75 meters per second. It strikes an object which could be a fruit of mass 200 grams. Then it goes into the fruit, and then both of them fly off together. And then you are asked, if the arrow sticks into the fruit and they move off together with a certain velocity, with what velocity are they going to move off together? That is a question. So we are going to look at the system before the arrow goes into the fruit. And then we are going to see that the total momentum of this system before the arrow goes into the fruit, before a particular event, then that total momentum will be equal to the total momentum after the arrow goes into the fruit and they stick together and fly off together. So let's calculate the total momentum before. So let's talk about total momentum before. You can see that it is equal to the total momentum of the arrow plus the total momentum of this system before the arrow strikes the fruit is equal to the momentum of the fruit, which is m1 u1 plus m2 u2. This is how we work out the total momentum of that system. Let's see. This will be 0.05 because it is 50 divided by 1000 kilograms times 75, and that I think gives us, let me just work it out just right now, 0.05 times 75, it will give us 3.75. By the way, this is 0 because the fruit is stationary, it is not moving, so its momentum is 0. So the total momentum is actually the momentum of the arrow, which is 3.75 kilograms meter per second or Newton seconds to the right. This is the total momentum of this system before something happens or before they collide. The principle of conservation of momentum tells us that the momentum after, which is, this is what we have here, the momentum after will be the total mass of this system, which will now be 250 grams, because it will be m1. Again, total momentum here will be equal to now m1 plus m2, all these times the common velocity. m1 plus m2 will be 250 grams. This one will be 0.250 times v, because we do not know how much velocity it is moving with. So this is where now the principle of conservation of momentum comes in. It tells us that the total momentum of this system before is equal to the total momentum of the system after. So we will simply put an equal sign here, and we get this total momentum after, which is 0.250 times v, is equal to the total momentum before, 3.75. And so we are going to divide 3.75 by 0.25, and we get a speed of 15 meters per second to the right. Remember, the total momentum before is 3.75 Newton seconds to the right. It means that the final momentum, or the total momentum after the two collide, is also to the right. And if we know momentum to the right, we know that momentum is to the right, then we should know that that velocity should also be to the right, because we know from the definition of momentum that the direction of momentum is the same as the direction of its velocity. I mean, the direction of the velocity of that object. So that is how you would use the principle of conservation of momentum to work out a question like that. Now, how about if the two bodies were already in motion? If they were in motion, for example, if this fruit was in motion and they happen to collide, we have looked at a situation whereby the two objects are in motion and we want to calculate the total momentum of that system. Again, let us look at another question where the two bodies are already in motion and we want to see what happens.